Okay, today's lesson is 12-2, angles and angle measures, and we're basically going to be talking about more angles on the unit circle, not just those created by our special right triangles. So, first off, let's talk about what an angle in standard position is. It is an angle whose vertex is at the origin and who has one ray as the positive x-axis. And we actually refer to that ray as the initial side. Okay, so this is the initial side, always is the positive x-axis. That's where it has to start every time. Now, the ending side or the terminal side of your axis can be anywhere. It can even be on here. We'll talk about that, or you saw it on your unit circle. This is 0. If we went all the way around, okay, if this right here is 0, then you go all the way around, then you're at 360 degrees. Okay, so notice the difference between this angle here and that angle there. Well, I hope you noticed that this one is going in a counterclockwise direction, and this is going in a clockwise direction. So counterclockwise are the kinds of angles that are positive, and clockwise are the angles that are negative. So that's a key feature that you got to remember. So when you put in your lesson check, pay attention to whether you put that negative sign, because it can count you all right or all wrong. Okay, so how do you draw an angle in standard position? All right, first off, 80 degrees. So you're going to find, always starting off with your 0, okay? And then, where's 80 degrees? Well, you know that this is 90 degrees. So 80 degrees is just going to be just shy of 90 degrees. So it's just an estimate, okay? You would draw an arc and then label it 80 degrees, okay? Negative 105, again, has to start here. Where's negative 105? Now, the easiest way to do a negative, it is in the opposite direction, okay? But if you know where your positive numbers are, so this was 90, and this is 180, and 105 is closer. So 105 would be something like this, which means negative of 105. You take the, find the positive, and then flip it over the x-axis. So if I take this and flip it over the x-axis, that's where negative 105 is. Positive 105 would be up here. If I flip that, negative 105 is down here. Now, another kind of angle that might cause you a little trouble is 600 degrees. Well, where is 600 degrees? Because here's 0. All the way around is 360. So what we do is we take, oops, I did not mean to do that. I didn't mean to do that either. But we take 600 degrees and we subtract 360 from it, and you get 240. So 600 degrees ends at the same place as 240. So that's what this little arc is telling you, is that I start at 0, I go all the way around, and then I keep going, and I end at this place right here. Now, when you have one or more angles that ends at the same place, so example, 240 degrees and 600 degrees have the same terminal ray. So when they have the same terminal ray, that's what we call, that's what that just said. Two or more angles in standard position with the same terminal side are called coterminal angles. And coterminal angles can be found by adding or subtracting a multiple of 360. So in this little diagram here, if I were to, they show you initially what is 420 degrees, because they went all the way around and then they went another part. So how do you figure that out? Okay, is if you take 420, just like we did, and subtract 360, then what do you get? 60 degrees. So we know 420 and 60 are coterminal angles. That's what this is showing you right here, this inside one. It's showing you that it went all the way around and then it went up to that place. So this here to here is just 60, but here starting all the way over and going around is 360, is 420. And if I take it and go in the opposite direction, then that means that I can take 60, and if I take 60 and subtract 360 from 60, then I get the other option, which is negative 300. Okay, so again, that was examples of how to find them. Here are some more of them. I'm going to do, it says find a positive measure and an angle with a negative measure that are coterminal. So coterminal means they're going to differ by a multiple of 360 degrees. So what you have to pay attention to in the directions, am I asking you for a positive one or a negative one? So this one I have to do both. So if I'm going to get a positive one, I'm going to add 360. So 15 plus 360 is 375 degrees. 15 minus 360 is negative 345 degrees. So 3b, I changed it because I wanted to do a radian value with you. If you have negative 3 pi over 4, and either way, I'm going to add 2 pi. And when I add 2 pi, your calculators will do that for you, or you have to change this to fourths, which is 8 pi over 4. But regardless, negative 3 pi over 4 plus 2 pi gives you 5 pi over 4. And negative 3 pi over 4 minus 2 pi gives you negative 11 pi over 4. Okay, now notice this one. Find an angle. Each of these examples we have added and subtracted 360 or 2 pi. Sometimes you got to go in the same direction twice, which is what I did up above. Find an angle that's positive. Well, if I subtract 360, I get 40. But if I add 360 to that number, I still have a positive one. So to get the negative, I actually have to just subtract 360 twice. Clearly, I'm having a really hard time talking. I think somebody came and got my tongue. But let's keep going. Okay, so how do we convert between radians and degrees? Okay, the biggest key, okay, is if you remember from your unit circle, where is pi, or where is 180? Where's 180 degrees on our unit circle? 180 degrees is over to the left. And over to the left, how many radians was that? It is pi radians. So that is our conversion factor. Now, what you want to remember is if you're going 2 radians, I say whatever you're going to needs to be on top. So if I'm going 2 radians, I'm going to have radians on top. If I'm going 2 degrees, I'm going to have degrees on top. That's what I'm going to multiply by to change an angle. It's kind of like if you're changing from inches to feet, then I want inches on top. I want 12 inches on top and 1 foot on the bottom. So look at this example here. It says rewrite the degree measure in radians and the radian measure in degrees. So that's my degree measure. I want to go 2 radians. So if I want to go 2 radians, then I'm going to multiply by 180 over pi. Now, what you got to remember, easy way to do it, if I've got a 0 in both of them, I can cross out the zeros. So that's 12 pi over 18. Again, you all have calculators to do that, but just to refresh your memory, okay, in case you don't remember, I'm going to go to the class calc because I know everybody can get to that. So even if your calculator doesn't do it, use class calc. And if you hit 12 divided by 18, okay, it gave me a decimal, but if you go click right here and you say give me the fraction, it'll change it to 2/3. Now notice I did not put the pi in there because the only thing I'm going to reduce is the fraction. So my answer, 12 over 18, becomes 2 over 3, or 2/3 pi. Okay, 4b says negative 3 pi over 8. I'm going 2 degrees, so I'm going to multiply by 180 over pi. And 8 goes into 180 45 times. 3 times 45, oh, notice my pi's cancel. And 3 times 45 is 135. Is it 135? 3 times 45 is 90. Yeah, 135. But remember, if it starts off negative, then it ends up negative. Okay, well, clearly I didn't do that very well. Okay, so not good with the math in my head. Oh, you know what it is? It's 4. 8 doesn't go into 180. 4 goes into 180. So what's left here is 2. So 3 times 45 is 135, and 135 divided by 2 is 67.5. So that's what you got. Okay, the last thing I got to talk about is arc length. Arc length is this. Let's see if I can go highlight it. This, it's a piece of the circumference of the circle. Okay, that's what they're talking about when they're talking about arc length. But when you are using, we have a new formula here. This is different from what you used last year. S equals R theta. You just have to make sure that theta is in radians every time you do it. So S is my arc length, R is my radius, theta is my angle, my central angle in radians. So this is the last example that we have. Monster truck tires have a radius of 33 degrees. So how far does a monster truck travel in feet after just 3/4 of a rotation, of a tire rotation? So in feet means that 3/4 of a rotation, I'm going 3/4 of a rotation. How far is that around my circle? Well, that, of course, if you think about your unit circle, 3/4 would be, if I started here, okay, 3/4 is going all the way right down here. So what angle is that? Well, hopefully you know that angle is 3 pi over 2. Okay, so now what is my formula? I'm trying to find the arc length. My formula is, what is it? S equals R theta. Okay, so S equals R theta. I'm going to write that down. What is R? My radius is 33. Now, my theta is 3 pi over 2, so I plug that in, and that's 99 pi over 2 inches. It's a word problem, so we probably don't want it in terms of pi. So that's 155.5 inches. But notice that the directions said that they wanted it in feet. So how do I change inches to feet? I use a multiplier just like I did before, which would be 12 inches on the bottom and 1 foot on the top, which is in essence dividing by 12 inches, which gives us an answer of 12.96 feet. Now, when you do this in Canvas, okay, y'all need to make sure that you are paying attention to the directions. If you want it to go give you and mark you right if you have the right answer, pay attention to the directions. A lot of times I let you off the hook on your units, especially in degrees, because Canvas can't grade it very well if you put the degree symbol in there. So you don't get it wrong. That's how I have to go back and look at some of them. But anyway, if you have any questions, hope this helps. If you have any questions, email me or join me in a live Q&A. Thank you very much. Y'all have a great day.